talking about a rational function, and we've had rational exponents. Remember, that is an exponent that is a fraction. This is a rational function. What that means, this is the notation for a function. Don't let that scare you. That's still like y equals, and it's a polynomial over a polynomial. What is a polynomial? It could be a binomial, it could be a trinomial, it could be a binomial over a trinomial, or a monomial over a monomial. Okay, all of those things that we've learned. Okay, so on here, this, we're just going to skip this for right now, because I don't even want to go there. There's no need. You can have, this is what they put it as, this is like your H and this is like your K, but your book used B and C. So I wanted to show you what the book uses. And B is really the horizontal movement, because what you're first going to identify is HK. Notice it's A over X minus H plus K. Very, very similar to our other ones in the warm-up. Okay, and it's a rational function, so it's a fraction there. H is the horizontal movement. K is the vertical movement, and you have asymptotes. Now, what is an asymptote? This is a line that the graph approaches at the end, but does not cross. My parent function is a over x. So this is it's a parent function right now. You're going to identify your asymptotes. Your asymptotes are x equals h and y equals k. The h is always the horizontal movement, how it moves left to right. So it goes with x equals. It's the x coordinate of the ordered pair. The k is the ordered pair, is the y coordinate of the ordered pair. So on here, my hk is actually 0, 0. There's nothing being subtracted from x, and there's nothing being added to the function. So my two asymptotes are x equals 0, y equals 0. What are those? X equals 0 is your y-axis, and y equals 0 is your x-axis. Now, we're going to make this very, very easy for you. We just have you substitute in the number 1 for x. Always the number 1 for x. So, 1 and negative 1. So when I substitute 1 in, I would have 1 over 1. So y would equal 1. So it's when x is 1, y is 1. When x is negative 1, y is negative 1. And you plot those 2 points, and you're going to say, what the heck is going on here? They're diagonal from each other. What your graph of a rational expression is, it has like 2 branches. It's 2 curves, and it gets closer and closer to the 2 asymptotes. And in this case, our 2 asymptotes are the x-axis and y-axis. It gets closer and closer, but never touches. It doesn't cross. Think about if x is 100, you'd have 1/100th. If x is negative 100, you'd have negative 100th. It's going to get closer and closer to those axes, but it will never cross it. These are called branches. These are your 2 graphs. So let's look at problem number 2. What would be my HK here? What's the H? What would I have to substitute in here to get this? 2. And what is the K? 0. So if I graph this, 2, 0, My asymptotes are x equals 2, y equals 0. X equals 2, you graph those first, and y equals 0. Notice, where do they intersect? They intersect at 2, 0. This is my new origin. Okay? So now when I'm graphing, I'm going from that intersection of the two asymptotes. And so here I'm going to graph my parent function, which is 1 over x. So when x is 1, y is 1. And when x is negative 1, y is negative 1. So you have 1, 1, and negative 1, negative 1. And you would have this as your graph. That just graphed it, that. It's same shape, it just got shifted to the right 2 units. Okay? On this one, Hans, what would be my HK on this? Okay, if I plug in 3 here, it'd be x minus 3. So it would be negative 3, 0. We always want to bring that x back to 0. What would we substitute in for x to make that back to 0? So here I have negative 3, 0. So I know that my asymptotes are going to go through there. They're going to be vertical and they're going to be horizontal. If I'd ask you what are the equations, it would be x equals negative 3, y equals 0. Okay, what are the 2 points? 1, 1, 1, negative 1 again, because my parent function is 1 over x. I take away. The parent function is always when x, h, and k are 0, 0. Yes?
So if we would label the asymptotes, would we go like x equals negative 3?
Yes, right here. These are the asymptotes. Okay? And from here, the intersection, you would graph these, and you are done graphing it. Okay, let's go to number 5. Taylor, what would be the HK?
0, 2.
Okay, number 5, that's 4.
Oh, sorry.
That's okay.
2, negative 3.
2, if I plug in 2 here, it'd be x minus 2.
Yeah, so negative 2, negative 3.
Negative 2, negative 3. I go and plot that point. At that time, you can draw your 2 asymptotes if you want to. They go through the HK. If I ask you to identify the asymptotes, you don't write this ordered pair. The asymptotes are lines. It's x equals negative 2 and y equals negative 3. Do you understand? Those are the asymptotes because they're lines. Okay? My parent function is y equals 1 over x. So Michael J., how would I move from here? Down 2. I already have negative 2, negative 3. How would I draw the branches? Okay, what's the parent function of this? Armand? Okay, this is the parent function. The parent function is just a over x. A is 1. So Michael, when x is 1, what's y? When x is negative 1, what's y? Negative 1. So from here, I go over 1, up 1. To the left 1, down 1. Are you with me? Questions on that? From this intersection, over 1, up 1, to the left 1, down 1, and then you draw your 2 branches. Do your branches ever cross those 2 asymptotes?
Nope.
No. If they do, you're going to get points taken off. They get closer and closer. Okay, now what's different on number 6 than all the others? Jake? There's a 2, so let's see how that affects things. Oscar, what's a HK?
Negative 2, negative 1.
How are you getting negative 2?
Oh, man. 1 and negative 2.
What is it? 1 and?
2.
So watch, Michael. You go 1, 2. So what are my asymptotes? They are x equals 1, y equals 2. These are the asymptotes. So here is x equals 1. Here is y equals 2. Now, Hazim, what is my parent function on number 6? Safa?
Is it 22 246?
No. What's the parent function? Adam?
Or y equals 2/1?
2 over x.
Yeah.
Right here.
Which is 1, right?
Okay, which is, now when x is 1, what is y? 2. When x is negative 1, what is y? Negative 2. So what happened here, okay, what happened here is that we're just really multiplying this by 2, right? The y. So here, from here, you're going over 1 up 2, and to the left 1 down 2, and here would be your graph. So the A affected the y coordinate here, right? Our x is always going to be 1 and negative 1. There's no reason to substitute anything else. When you divide by 1 and divide by negative 1, you keep life simple. Okay, and that's what we want to do. Keep things easy, easy peasy. Okay, so let's turn the page. Sorry this wasn't a colored thing. It wasn't. Okay. You can think of graphs of functions with similar features as family of functions. You have studied 6 families of functions this year, and we've just talked about some today. Their properties and graphs are shown below. Here, y equals mx plus b. That would be a line. Here, the quadratic. If this is my line of symmetry, it would be like this. The quadratic goes this way. This is a parabola. Okay? Here the parent function is y equals x squared. The parabola with the axis of symmetry is x equals negative b over 2a. The greatest exponent is 2. Okay, things that we know. Sorry that this is so light. Here, I would like you to change this to x minus h plus b. Okay? Here, the parent function is the absolute value of x. The shift is h units, and this is k units. So the vertex is at hk. Now, we talked about this, that it is a v. Exponential, we talked about this. This is when the x is in the exponent. And when that happens, we did this in our chapter 8, it had rational exponents. It became a curve. And I'm sorry, this is so light. This is terrible. I didn't realize it was this terrible. Okay, it would go like through this. It would be a curve, and we talked about the asymptote at that time going up. As this increases, it will go up. It will be a growth when b is greater than 1. It's a decay when b is in between. Then it goes down like this, that as x increases, y decreases. Square root function. Once again, we had the hk here, or we have hk, and then we had xy, 1, 1, 4, 2. And it was a banana curve. Okay? And the last one is what we just did here. And this is so light. H and K. This is asymptotes are x equals h, y equals k, and you have 2 branches. And the asymptotes, they do not cross. So if you have something like this and like this is our sixth family of functions that we have studied this year. Linear, quadratic, absolute value, exponential, square root, and now rational. And you should be able to identify the equation just as it's written and have a visual picture in your mind of what the graph should look like. You have to have that so you know what to look for. You always look for H and K, but what is H and K? So, in 12.1, not only do you have to graph things, but you have to identify the functions. And I want you to tell me as much as possible. On this one, what kind of a function would this be in the family of functions? Exponential. Very good. Would it be a growth or a decay?
Growth.
Growth. And why is it a growth? Okay, b is greater than 1. b is 5 right here. It would go like this. It would go off like that. Okay. What is this one? Linear. And Jordan, what can you tell me about this one? It's linear. What can you tell me about the line? It's what? It's straight. Most lines are. Otherwise, there are curves. There's something else you should be able. What does a 5 stand for? Okay, I think we all hear it's slope. Is 5. Would it be going uphill or downhill? Uphill because the slope is positive. Where does it intersect the y-axis? What, Max? 0, 0. Good. B is 0, is 0. Very good. So you can tell me a lot more on that one. Okay, Noah, what kind of a function is this?
That is
What do you think it is, Anna? Let's see. What kind of a function? Uh-huh. That's what I said. No, I said Annika. Oh, sorry. I did say it. But what would you say, Annika? What is it? Mm-hmm. Farnham, what is it? Rational. How many think it's rational? You do? It's not rational. If x was in the denominator, it'd be rational. Armand? Exponential. Is x in the exponent?
No.
It'd have to be like this. Adam? Linear. Very good. What is the slope?
1/5.
Very good.
Yeah, sure.
Is it uphill or downhill?
Okay.
Uphill because the slope's positive, and what's my y-intercept? 0, 0. Okay, Farnham, what's the D then? Rational because?
because the x is in the
Okay, it is. And what would be my two asymptotes then? Max?
25
No. Michael D? That's HK is 0, 0. I agree with that. So what are my asymptotes? Yes, Hans? What were you saying? Kira?
X equals 0, Y equals 0?
They are two lines. It's not an ordered pair. So what does my graph look like? Two what? Branches. And then what would they pass through? 1, 5, and so if I were to graph it, here are my two asymptotes. I'd be 1, 5 and negative 1, 5. It would look like this. Look how similar all of these are. This is exponential because the x is in the exponent. This is linear because x is the base. 5 is a coefficient. This can be written as 1/5 x. This is the base. 1/5 is a coefficient. Here you're dividing by x, so it's a rational function because it's a fraction of polynomials. The x is in the denominator. Okay, now on this one, what would this be? Is the variable in the exponent?
Oh, no.
Farnham. Quadratic. So what would be my graph of a quadratic? What would it look like? It would be a parabola. And what would be the HK? What would be the HK, Elliot? On this one? Don't know? If I would put it in this form, x minus h squared plus k, what are you substituting in for h and k to get there? Elliot, what am I substituting in? Is anything being subtracted from x? Is anything being subtracted there? No, so that's 0. Is anything being added? No, so the origin is the vertex. It's the vertex of the parabola. And then you'd go over 1, up 1, and over 2, up 4, and you would have a parabola. No, you go over 1, up 5, I'm sorry, and over 2 and up 20, because we have to multiply it by 5. So it'd be a very thin, a narrow parabola. It's going up at the ends rather than going down. Because the farther the A is from 0, the thinner, or the more narrow it is. Okay, what is this going to be? Darren, what kind of a graph is this? Square root. What else do we call it? Or radical. What's your HK? 5, 0. What's the shape of it going to be? Safa? A banana. It's just going to go off to the right. So you have it at 5, 0. And you go over 1, up 1, over 4, up 2. It goes off to the right. Notice all of these look a lot the same. I'm using 5 and x. Matthew, what is this one?
Absolute value.
Absolute value. What does it look like? A V. Excellent. And what is my HK or my vertex? 5, 0. And it will look a lot like, it'll go over 1, up 1, over 1, up 1, stop. But it will look a lot like a parabola. Okay, Eric, what is this one called? Exponential. And why is it exponential? The variable's in the exponent. Okay, so Is it going to be a growth or a decay?
Okay.
Why would it be a decay? What's my base of the exponent? Isn't it greater than 1? So it would be, it's greater than 1, so it is a growth. So I know since it's a growth, it's going to go up like this. If it was a decay, I don't want to, well, I'll just show you down here. A decay exponential, have this make sense to you, you guys, we're at the end of the year. It would be declining as x increases. This is when b is in between 0 and 1. B is not going to be negative. Okay? And the last one is what? Emma. It's rational because we have a variable in the denominator. And what's my HK? Negative 1, 0. What would be the asymptotes? Those would be your 2 points. Your asymptotes are the 2 lines. They are x equals right, and y equals 0. So when I go and graph that, x equals negative 1 would be right here. Y equals 0 would be this. Okay? And then your 2 numbers from here, your 2 ordered pairs are 1, 2, and negative 1, negative 2. So you go over 1, up 1, 2, sorry, and over 1, down 2. And your graph would look like this. And how we describe that right now is 2 branches. In Algebra 2, we will be calling them hyperbolas. A hyperbola. Okay? Any questions on that? Okay, so that is it. So I'm going to